Okay, recursively defined sequences. So a quick review what we already have studied about sequences. So an arithmetic sequence, when a sequence has a common difference between each pair of consecutive terms, it's called an arithmetic sequence. That common difference, or the common amount being added to each term to obtain the next, we call that our common difference. Geometric sequence is when we have a common ratio between consecutive terms. In other words, we're multiplying by the same amount to get to the next term. So using those, we have explicit rules for those sequences. An explicit rule helps us to find a specific term. Let's say we have a sequence of 6 numbers, and then we want to find the 35th number. If we were to continue out that sequence, you could use explicit rules. So the explicit equation for an arithmetic sequence is a sub n is equal to a sub 1 plus n minus 1 times d, and d's are common difference. And then we have the explicit equation for a geometric sequence, which is a sub n is equal to a sub 1 times r to the n minus 1 power, where r is the common ratio. Those are all things that we've already studied here. So to kind of build on top of that, we're going to go to a different type of rule, which is called a recursive rule. Okay, the explicit rule helps us to find that one specific term, whereas the recursive rule helps us to find the next term of the sequence. It's kind of the stuff you do intuitively anytime you're finding the next value of a pattern. So if I gave you the sequence 2, 4, 6, and said, okay, well, what's the next value there? Most people would say, well, the next value is just 8, right? It's 8 because I'm adding 2 every time. Okay, and really, that's what this recursive rule for an arithmetic sequence says. An arithmetic sequence says, hey, if you have a term you're trying to find, a sub n, remember that n just represents like its position. Okay, so if we were to, excuse me here, if we were to build a table out of this, okay, well, this was the first term, second term, third term, and this is the fourth term. Okay, so remember this represents n. This is a sub n. Okay, so the fourth term, so a sub 4, is equal to a sub n minus 1, or the third term, which is a sub 3, right? 4 minus 1 is 3, plus our common difference of 2. And so if we put all that in, we'd say, okay, well, that means a sub 4 is equal to, well, a sub 3 is 6. 6 plus 2 is 8. So the fourth term is 8. Okay? And really, it's what you do in your head, right? I mean, it's the intuitive process. But we have to have a general formula that we can express it by, and then we can utilize that to go back and forth between explicit rule and recursive rules and use that to be able to communicate what we're trying to come up with in terms of another value, especially if we're writing, say, a program or something. Okay, so let's say, for instance, I want to use the geometric sequence. Okay, and let's say I have n is 1, 2, 3, 4, and 5. So let's say we have 5 terms, and let's say a sub n. We have 2, 4, 8, 16, and I want to know the next term. Okay, well, what's happening here is if I want to find a sub n, okay, so in this case the fifth term, so that would be a sub 5, is equal to a sub n minus 1. Well, if n is 5, that means n minus 1 is 5 minus 1. And we're multiplying here. What are we multiplying by? Well, each time we're multiplying by 2. So it's times 2, or times 2. Okay. This, by the way, is our r here. And generally, I know that up here it says r times a sub n minus 1. I put a sub n times r. It means the same thing. You usually see it in this format, though. Okay. So really, that just means the fifth term is equal to the fourth term times 2. Or it's equal to the fourth term, 16, times 2, which is 32. Okay, so our next number is 32. And I know you could do that quicker just by doing it in your head, but that's how the pattern works. So the recursive rule is really something you do in your head intuitively. Okay, let's go ahead and kind of look through these, all right, and see how we're using them. Write the first 6 terms of the sequence, and then graph the sequence. Okay, so remember the top is always where we put our term number. So these would be your n's up here, okay? So when n is 1, 2, 3, 4, 5, and 6, what is a sub n? Okay, well, a sub 1, right, when n is 1, this would be a sub 1. Well, a sub 1 is 3, or the first term is 3. They tell us that. And a sub n equals a sub n minus 1 plus 2. Well, we've got to recognize that this is adding 2. So this right here, it's one of these different equations we saw. It's either this one, or these two. Okay? So one thing that's helpful is to start writing down on the top of your paper each time what your different rules are. Okay, so if I wanted to kind of go through that, I could say, well, I have my explicit rules, okay, and then I have my recursive. All right, and then I have my arithmetic, and I have my geometric. Okay, so when I'm looking at, I wrote AR all the way over there. Okay, so when I'm looking at these, I can just kind of quickly maybe write down my rules. Okay, so my explicit rule for arithmetic, remember that's just a sub n is equal to a sub 1 plus n minus 1 times d. And for geometric, it's a sub n is equal to a sub 1 times r to the n minus 1 power. And then my recursive rules for arithmetic, a sub n is equal to a sub n minus 1 plus d. And then for geometric, a sub n is equal to r times a sub n minus 1. Okay, so those are my rules right there. So looking at this, I can say, well, notice that all of them have a sub n or a sub 1, okay, with the exception of these two. And what's important is when you do the recursive rule, you always need to list a sub 1. Okay, so at the end, you're always going to list what a sub 1 is, because it tells you where your starting point is. So in all of these rules, you actually need to know a sub 1. Okay, so like for instance, on this first graph, it tells you a sub 1 is 3. All right, and then it gives you a rule, a sub n is equal to a sub n minus 1 plus your difference. Well, that is right here, it's a recursive. My difference is 2. That means I'm adding 2 every time. Okay, so this is 5, 7, 9, 11, and 13. All right, so we're adding 2 every time there. Remember, that's very similar to what's, well, it's not similar. It's a linear relationship. Okay, we have a rise and a run there. All right. The other thing to note here is that when we're graphing it, we only have to graph it in the first quadrant, our positive quadrant, because our values that y would be and our values that x would be are both positive. Remember, n is the same thing as your x. A sub n is the same thing as your y. So when I'm graphing this, that's my n axis, and that's my a sub n axis. Okay, and so I have my 1, 2, 3, 4, and 5, and 6. And then I'm not going to have enough to if I go up by 1, so I think I'm going to go up by 2. So this will be 18 right here. All right, and that would be 2. Okay, so 1, 3, so it looks like we're there. 2, 5, 3, 7, 4, 9, 5, 11, and 6, 13. Now the last thing to note here is this is discrete data. It makes sense to connect the dots or draw a line through the dots, okay? Because you don't have, like n represents your terms. You don't have a 1.5 term. So think of it as like places in a race. You have a first place, second place, third place, fourth place, fifth place, sixth place. We don't have a 1.5 place, all right? So there's nothing in between 1 and 2, so we just have the point there. But you can tell it's a linear progression there. Okay, Let's go ahead and look at another one here. A sub 1 is 1. Remember, here's n, and here's a sub n. There's 1, 2, 3, 4, 5, and 6. Okay. Well, a sub 1 is 1. And then we're given this pattern. Notice you don't see any addition signs, so that means we're multiplying. And we're multiplying by our ratio. We're using this is a recursive rule for geometric here. The ratio is 2, means we're multiplying by 2. Okay, so this would be 2. And if we continue that, 4, 8, 16, and 32. Okay, so once again, I'm just going to use my positive positives. Here's n. Here's a sub n. I think I'm just going to go up by 4s this time. Okay, so 4, and that would bring me all the way to 36. So I'd have 1, 1, 2, 2, 3, 4, 4, 8, 5, 16, and 6, 32. And once again, it has to be discrete data. There's no like 1.5 place. Okay, this is discrete data. All right, and notice this is exponential. When you're multiplying, we are exponential. All right. Well, hopefully that makes sense. If not, make sure you ask your teacher there. Okay, writing recursive rules. So write a recursive rule for each sequence. Don't forget to list a sub 1, the first term. All right. So first thing I'm going to do, since it reminded me, is list my first term. My first term, remember you can always put these in tables, right? There's 1, 2, 3, 4, and 5. So this is n, this is a sub n. Oh. All right. And so my first term, a sub 1, is equal to 81. Okay, and then the pattern, what's happening every time? Well, it looks like I could divide by 3 here. Divide by 3 is the same thing as multiplying by 1/3. And we want to make sure that that continues. So, yep, that is 1/3. Yep, that's 1/3. All right, so it looks like we are multiplying by 1/3 every time. All right, so what does that mean if we're writing a recursive rule? Well, recall, our recursive rules, once again, always good to have them written on top of your paper. I'm not going to rewrite them again here, but kind of glance back at our previous slide. Our recursive rule, a sub n is equal to r times a sub n minus 1. So we just started out, a sub n is equal to r. R is 1/3. That's our common ratio, times a sub n minus 1. And then we have to list a sub 1. A sub 1 is 81. So we always need to know a sub 1, and then you figure out what your ratio is. Okay, so let's go ahead and look at this one here. We're going to, doesn't look like we'd multiply very nice there, and it definitely wouldn't multiply by the same amount here. You're going down by too much. So let's see, we'd go, actually we're increasing by 15 every time it looks like. Okay, and since we're adding, that is a common difference. So D is equal to 15. A sub 1 is always important. That is equal to negative 22. So once again, if you struggle with that, put your table, right? 1, 2, 3, 4, and 5th term, so n and a sub n. Okay, and so my formula, a sub n, my recursive rule for arithmetic, right here, a sub n is equal to a sub n minus 1 plus d. A sub n is equal to a sub n minus 1 plus my difference of 15. And I've got to list that first term. The first term is negative 22. It's important to list the first term because that tells us where to start our pattern. So starting at negative 22, go up by 15 every time. Starting at 81, multiply by 1/3 every time. All right. Write an explicit rule for each recursive rule. Okay, so a little different here. So now it might be nice to have all of our rules up here again. So I'm going to go ahead and do that. Explicit and recursive. Let me not spell the whole thing out. We'll go arithmetic and geometric. Okay. So my explicit rules, kind of go through that excuse me, I got a bug in my throat there. Kind of go through that process again. My explicit rule for arithmetic is a sub n is equal to a sub n minus, or excuse me, I was doing the recursive rule, a sub 1. Oops. All right. My pen just got stuck there. There we go. All right. A sub 1 plus n minus 1 times d. Okay. And then the geometric, a sub n is equal to a sub 1 times r. Oops. Times r to the n minus 1 power. Okay. Recursive, a sub n is equal to a sub n minus 1 plus d, and then we need to know what a sub 1 is, so we make sure we list that, and then a sub n is equal to r times a sub n minus 1, and once again we need to know what a sub 1 is. Okay, so there we've got it. So we're writing an explicit rule, so we're focusing right here on this column. For the recursive rule, well, the recursive rule tells us things. So when we look at this right here, first it says minus 8. Well, notice in our recursive rule, that's our difference. So d equals negative 8. They also tell us a sub 1. A sub 1 is 12. And we always need to know a sub 1, no matter which of the rules we're using. So if we're writing an explicit rule, well, the explicit function for arithmetic is a sub n, or the equation for arithmetic, a sub n is equal to a sub 1 plus n minus 1 times d. And we know all these pieces. A sub n is just like our y. A sub 1 is our d, negative 8. Excuse me, a sub 1 is not our d. A sub 1 is 12 plus n minus 1, and our d is negative 8. And I'm going to put negative 8 in parentheses because I'd multiply that. And I'm actually going to multiply this out now. Okay. So I'm going to distribute that. So I end up with 12 minus 8n plus 8. Then combining like terms, 12 and 8 is 20. So I get negative 8n plus 20. Okay, and that's a sub n. Now I'm going to use that. This is my equation. This is all they asked us to do. However, that's an important piece right there. And I just want to point out one little thing here. If I were to build a table with the information they gave us, this is going to help us with a later problem. Okay. If I had n and a sub n, and they tell me that we start at a sub 1 is 12. Notice I left an open space there. It's 12. And my difference is 8, that negative 8. That means I'm going down 8 every time. That means this is 4. That's the second term. The third term is, yep, it's negative 4. And the fourth term would be negative 12. And we just keep going. Well, what I want to point out is this term. What term is this? This is called the 0 term. That would be a sub 0. And if we were graphing a sub 0, right, a sub 0 would be not right here at 1, it would be right here. And we call that the y-intercept. And you'll notice if I were to go the other way 8, I would end up at 20. Right? To go from 20 to 12 is minus 8. So this would be 20. What does that mean? It means I have a y-intercept of 20. And where do we see that y-intercept? We actually see that y-intercept right there. So that number right there, that 20, is a sub 0. Why is that important? Well, because if I know a sub 0 and every one of these equations needs a sub 1, if I know a sub 0, to get to a sub 1, I just add the difference. I add negative 8 to it, and now I'm at a sub 1. That is a key piece of information. That's important when you're dealing with the explicit equations for arithmetic sequence. It won't matter as much. It won't matter at all with the recursive, or excuse me, with the geometric. Okay. All right. So we'll use that later. But All right, a sub 1, this next one, a sub 1 is equal to 14.2, so we always need to know a sub 1. And looks like we're multiplying here. Our ratio is negative 0.5. We are multiplying by a half, right? That is this, oops, that is this one right here. Oops, sorry, right here, recursive rule. So if I want my geometric for explicit, that's a sub n. It's equal to a sub 1 times r to the n minus 1. And a sub n is equal to a sub 1, which is 14.2, times r. And since it's a negative, I'm going to put it in parentheses, to the n minus 1. And that is our explicit formula. Okay, and so that's our equation for the geometric there. Just double check and make sure everything looks good. Okay, so let's go ahead and move on here. We're going to go the other way now, recursive to explicit, or we're going from an explicit rule to a recursive rule. Okay, so once again, important to have your formulas down. So if you kind of write them down, I'm abbreviating even more every time. Explicit, geometric, arithmetic, explicit, recursive, arithmetic, geometric. Okay, if I'm kind of just quickly going through them, and remember you've got them on the previous. If you already wrote them down and you kind of have your printed out slides, then that's good to go. But all right, so we have a sub 1, or excuse me, a sub n is equal to a sub 1 plus n minus 1 times d. Kind of squeezed myself in there. A sub n is equal to a sub 1 times r to the n minus 1. All right, recursive. A sub n is equal to a sub n minus 1 plus d. And then we need to know a sub 1. And then a sub n is equal to r times a sub n minus 1. And we need to know what a sub 1 is. Okay? And so here we're given the explicit rule. So this is explicit. Just like this one down here was explicit. Notice it's a linear equation. Here's my slope. And my slope on this also happened to be my common difference. Okay, and here's my y-intercept, which actually happened to be a sub 0. Okay, so when I look at this one, well, here's my slope. If you think y equals mx plus b, so that's your common difference. And this is a sub 0. Oops. And so if I need to know d and a sub 1, well, I know d. It's negative 3. A sub 1, well, think about your table. Start at 0, 1, 2, and so on, right? And 0 we know is 4, and you have a common difference of negative 3. That means we're going down 3, which brings me to 1. So a sub 1 is 1. How does that help us? Well, now we have everything we know for a recursive rule for arithmetic. We know a sub n is equal to a sub n minus 1 plus our difference of negative 3. So you don't have to write it as plus negative 3. You could just say, if you wanted, minus 3. And then we need to list a sub 1 out. A sub 1 is 1. That's where we start our pattern. That is how the a sub 0 helps us out. Okay, just to add color to our life, we'll switch it up there. Hey, this one is multiplying. Okay, so it is a explicit rule for geometric. And notice a sub 1 is listed first, so that's a sub 1 is negative 2. R is what our power we're raising to the n minus 1, so r is 4. And so writing this out, a sub n is equal to r, 4, times a sub n minus 1, or yeah, times a sub n minus 1, excuse me. And then we need to list a sub 1 is equal to negative 2. That's where we start our pattern at. All right. Well, let's go ahead and do one more thing. And this, I'll be honest with you, this is kind of the most complex piece of this. Sometimes you don't have a geometric or arithmetic sequence. So one pattern to look for is that of using sums of other consecutive terms. So if you look at a pattern, always try for geometric arithmetic. So say, hey, can I multiply something by 4 to make 5? And then multiply it by the same something to get 9, and then to get, no, I can't. Can I add? Well, I can add 1, and then I can add 4, and then I can add 5. Okay, that didn't work. Okay, and I try that on all of these, and none of them would work. So the next thing to do is to look at your first two terms. My first term, a sub 1, is 4, and a sub 2 is 5. Okay, and after you've kind of glanced at those, go ahead and look at the third term. Say, how can I get the third term, which we write as a sub 3, how can I get that using the previous two? So that's a pattern to look for. Okay, so if I try to add 4 plus 5, that does make 9. I could say, well, I could add a sub 1 to a sub 2. Remember, this is like if we were to list our term numbers: first term, second term, third term, fourth term, fifth term, and sixth term. So to get the third term, 9, add the first and the second. Okay, so it would give me, if we were to switch up the colors here, that would give me 9 equals 4 plus 5. And that works. Okay, what you want to do is see if it works for all of them. So I did that here. That would be the fourth term is equal to, well, it'd be the previous two, a sub 2 and a sub 3, if we keep that pattern, right, the 2 before it. So 5 plus 9, if we're kind of looking at it, let's say, okay, the fourth term is 14. Is 14 equal to the second term, which is 5, plus the third term, which is 9? And the answer is, yep, it is. And we try the next one and say, okay, well, the fifth term is equal to, it would have to be the third plus the fourth. And once again, you check your work. You'd say, okay, the fifth term is 23. That's equal to the third, which is 9, plus the fourth, which is 14. And I just noticed that I wrote the fourth wrong, so let me fix that. This should be not just 4, it should be a sub 4. And it does work out, though. I'm going to go ahead and erase these over here. We'll need those here in a minute, but I don't want to scrunch myself in there. And then the sixth term. Well, the sixth term would have to be equal to the fourth term plus the fifth term. Well, and once again, let's check it out. Okay, the sixth term is 37, and that's equal to the fourth term, which is 14, plus the fifth term, which is 23, and yep, it looks like it works out. So the first thing is to do is to figure out the pattern, which we have done. The next thing to do is write it in a sub n format. How does that work? Well, it works like this. We say we want the nth term, a sub n. Okay, well, how do I get from this location where n was, how do we get from that to our solution? So like when I was dealing with a sub 6, that's this one right here. How did I do that? Well, what I did is I said, well, a sub 6 was equal to the fourth plus the fifth. So look at it this way. You're starting at, I'm going to use this number. You're starting at 6, and you're adding the fourth position and the fifth position. So the sixth position is equal to that position, which is 2 behind it. So the way we write that is n minus 2, where the whatever position we want is equal to the position that's 2 behind it, plus the position that's 1 behind it, right? Because that was the fourth, which was 2 behind 6, and fifth, which was 1 behind 6. So the position that's 1 behind it. Okay, and that works here as well. The fifth position, the number in the fifth position is equal to the number in the third position, which was 2 behind it, plus the number in the fourth position, which was 1 behind it. So a sub n is equal to a sub n minus 2 plus a sub n minus 1, given that a sub 1 is 4 and a sub 2 is 5. And we have to give those two because we don't have any numbers behind those. So we have to at least list the first two to get our pattern going. That's how we write that. So it's really writing your pattern based on the position they're in. Okay? Now addition doesn't matter. We could have said, well, we're just going to add a sub n plus minus 1 plus a sub n minus 2. We could have added in the other order and it'd been fine. That's commutative property of addition. Okay, well, let's try another one here. Notice this one, 1 and 0. Let's go to the third term. Okay, the third term. How can we use the previous two terms to get that? Well, you could try adding 1 plus 0 is 1. That didn't work. You could try subtracting. 1 minus 0 is 1. Okay, well, maybe subtract the other way, 0 minus 1. Okay, that worked. Okay, so we're taking the second term and subtracting the first. So the second term minus the first. Once again, I can't stress enough that it's important to check it. Okay, the third term is negative 1. The second term is 0, and the first term is 1. And negative 1 equals 0 minus 1. So if it helps, again, right above them, just list what they are. Okay, this would be the first term, the second term, the third term, the fourth term, the fifth term, sixth term. So really we're dealing with this being n and this being a sub n, right? And so we could try the next one. We could say, okay, well, the fourth term. Well, the fourth term is equal to, we would have to say the term right behind it. Like we're keeping this pattern, the third term was equal to the term right behind it minus two terms behind it. So the term right behind the fourth would be the third, minus two terms behind the fourth, which would be the second. Okay, so we'd have to like put in the numbers just to make sure we're doing it right. We'd say, look, the fourth term is negative 1, and that's equal to the third term, negative 1, minus 0. Second term. Hey, and that works out. Okay, so let's go ahead and give another one a go. Okay, so now we have the fifth term. The fifth term is equal to, well, we'd have to go the term right behind it, so the fourth term, minus the term, two terms behind it, so the third term. And so once again, checking it out, that is the fifth term, which is 0, is equal to the fourth term, which is negative 1, minus the third term, which is negative 1. And here's where you'll make a mistake if you're not showing your work, because negative 1 minus 1, that's a plus, right? That changes to a plus. So it's negative 1 plus 1, which is 0. And that works out. Okay, so we try the last one. A sub 6 is equal to the, well, it's equal to the term behind it, the fifth term, minus the fourth term. Okay, and double checking it. Again, the sixth term is 1. That's equal to the fifth term, which is 0, minus the fourth term, which is negative 1. 0 minus negative 1, those become plus, which is 1, and it works out. So really, what we're looking at, when we think of it as a sub n, putting all this together again, a sub n is equal to, well, how are we getting there? So we're taking the 3 and we're going, so when we were at the third term, we took the second term and subtracted the first. So the third term, we took 1 behind it, so a sub n minus 1. And then we subtracted 2 behind it, the first. Okay, so we subtracted a sub n minus 2. So think of positions. So the third position is equal to 1 position behind it minus 2 positions behind it. So 1 is 2 positions behind 3, or we have to go back 2 to get to 1. We have to go back 1 to get to 2. We have to go back 1 to get to 3. We have to go back 2 to get to 2. We have to go back from 5. We have to go back 1 to get to 4. We have to go back 2 to get to 3. Go back 1 and go back 2. And then we state the first term has to be 1, and the next term has to be, or the second term has to be 0. So we state what the first two terms are, because we can't come up with them otherwise. Okay. Hey, one left. Last one. All right. So let's try this. Actually, that's the first term. So let's go to the third term. Third term is a sub 3 is equal to, well, let's try adding 1 plus 0 is 1. All right, that works. Is 0 plus 1 negative 1? That doesn't work. How about 1 minus 0? That works. How about 0 minus 1? That works. 1 minus 1. 1 minus negative 1, excuse me. Okay, that works. So we are subtracting 1 minus 0. So that is the first term minus the second term. Okay, which would mean, and I'll do the check here in a minute with all these. This would be a sub 4 is equal to, and it helps sometimes once again to have this above here. Right, first, second, third, fourth, fifth, and sixth. And this is n, and this is a sub n. Okay, so the fourth term is equal to the second minus the third. Okay, and this would be the fifth term is equal to, well, it's equal to the first, or excuse me, the third minus the fourth. And the sixth term is equal to the fourth minus the third. Okay, and then just double checking our work here. You usually get a little faster at them. The third is 1, and that's equal to the first, which is 1, minus the second, which is 0. That checks out. The fourth is negative 1, and that's equal to the second, which is 0, minus the third, which is 1. That checks out. The fifth is 2, and that's equal to the third, which is 1, minus the fourth, which is negative 1. 1 minus negative 1, that's a plus, yep. And then the sixth, which is negative 3, is equal to the fourth, which is negative 1, minus the third, which is 1. Negative 1 minus 1. Oops, that didn't work out. Oh, there's a reason it didn't work out, though. I messed up right here. That should have been a fifth. All right, good thing I checked here. That needs to be a fifth. All right, if we're following our pattern, which means this is no longer a 1, it's actually a 2. And negative 1 minus 2 is negative 3. So what did we get there? Well, we have the pattern a sub n is equal to, notice you had to go back 2 spots, a sub n minus 2, and you're subtracting, you had to go back 1 spot, a sub n minus 1. All right, and we have to say a sub 1 is equal to 1, and a sub 2 is equal to 0. All right, and there we've got it. All right, I think that's all I've got for you. Yep, good lucky.